Okay, yeah, algebra, I'm taking a kid to the doctor today. She's healthy again. She just has a checkup. But tomorrow, when I come back, we'll go through all of the homework that we need to turn in and any questions that we have. But I want to get a start on 6.3. A lot of you guys know how to do this stuff already, but we're talking about rational exponents and taking roots. So that would be like square roots. So like the square root of x. If there's no number here, you assume that it's just a square root. Sometimes they'll do one of these to you where it's a cubic root, or you can have a fourth root, which looks like that, or a fifth root, or anything like that. Those guys all are roots. If we want to write those as exponents, like the square root of x, we'll talk about this here down below, but this is like x to the 1/2 power. These two things mean the same thing, okay? Now, if the square root is x to the 1/2 power, the cubic root is x to the 1/3 power. So these two things mean the same thing. It's just a different way of writing it. This guy would be x to the 1/4 power, and so on and so forth. So when you get exponents that are fractions, that just means a root. So a square root, a cubic root, a fourth root. That's how these two go back and forth between the two, okay? All right, so let's talk down here when we're talking about, like, let's say the square root of 36, okay? They would just write it like this, square root of 36. They wouldn't put a 2 here, but the square root of 36 is just saying, what do you take times itself to get 36? Great, that's going to be just 6, right? 6 times 6 is 36. Now, if they say take the square root of like negative 36, we know that you can't take square roots of negative numbers, right? Like 6 times 6 gives me 36, but negative 6 times negative 6 will give me positive 36 as well. There's no way of getting a negative there, okay? So what this gives me is 6i, because an imaginary number is what it's going to be if it has a negative underneath of a square root. Now, that is only for even roots, right? Like to the second root, or the fourth root, or the sixth root. If, let's say, you have the cubic root of, let's say, negative 8, right? That is saying, what do you take times itself 3 times to get negative 8? Well, negative 2 times negative 2 times negative 2 will give me negative 8. So this one is not an imaginary number because he's a cubic root and not a square root, okay? So I'm going to put a little star. You can take odd roots of negative numbers, right? And so I think we've talked about that before, okay? So if it's a cubic root or a fifth root or a seventh root or something like that, you can take it of a negative number because 3 negatives are going to keep it as a negative versus 2 negatives make a positive. So I will never get a negative as a square root, okay? All right, so there's that. That's kind of what this table down here is saying. Let's go to an example. So here, okay. They are asking us to simplify. The plus and minus, don't let that confuse you. That's just going to continue on our answer. So we have plus and minus, and we're just going to take this bit by bit, okay? I know that your guys' calculators will do this for you, but if we take the square root of 25, that's saying what do you take times itself to get 25? We should know that. That's 5, right? But then it's asking, what do we take times itself to get x to the 4th power, okay? So I have to take x squared times x squared to get x to the 4th power. So if I take the square root of x to the 4th power, it's just x squared, right? Okay, so that's how that works. Now, some people get a little bit confused when we get to like part B, okay? That negative, just let him chill. He's on the outside of the square root, so don't think that's an imaginary number because he's not inside here. He's just going to chill. He's just going to hang on the edge here. Okay, this whole thing is being taken to the 12th power. So it's like saying y squared, you don't have to write this down, but y squared plus 7 times another y squared plus 7 times another y squared plus 7, 12 of them. That's what that means, right? 12 of them, okay? So this is asking, this square root is asking, how many of these do I have to take the times themselves to get 12 of them, right? Okay, and this is where people get it backwards, okay? When you have exponents, all you do is divide them by what your root is. So if I'm taking the square root, that divided is just going to give me 6, right? So this, if I pop it out of the square root, is just going to be that to the 6th power. It is not the same as taking the square root of a base number. The square root of 25, you're not just going to divide that by 2. But the square root of your exponent, like x to the 4th, you do divide the 4 by 2, okay? Like you divide the 12 by 2, okay? So let's put that off to the side over here. Base numbers. Take the square root. I'm going to just say take the root because we might not have a square root. It might be a cubic root, okay? Exponents. Divide by the root. Okay, so we'll have some more practice here in just a second, okay? So this next one, part C, I'll leave that up there. But this next one, part C, so I'm over here, okay? We are doing the cubic root, so that's what that 3 is there for, the cubic root. And I have 3 parts. I have 343, I have a to the 18th power, and I have b to the 6th power, okay? So I have those 3 parts, all right? I'm going to look at that 343 here. Okay, that is a base number, so I'm going to actually take that root. I'm going to say to myself, what do I multiply by itself 3 times to get 343? Okay, you can do it in your calculator. I'll show you tomorrow, if you don't already know, how to take the cubic root. Your calculator should be able to do it, but the cubic root of 343, if I do it, I think it's 81. No, it's not. It's 3. No, it's not. Oh, man. It's 7. It's 7. So if I take the cubic root of 343, this number is 7. Okay, now that was actually taking the root. 7 times 7 times 7 gives me 343. Okay, it doesn't take very long before small numbers become large numbers when you're multiplying. Okay, but when I take a to the 18th power, all I'm doing is looking at this 18 and I'm dividing by 3. I'm not like, what's the cubic root of 18? No, I'm dividing the 18 by 3, and 18 divided by 3 is 6. So this is a to the 6th power. Now I do b to the 6th. That's an exponent as well. I take 6 and I divide by 3, and that is 2. So this is b squared. All right, so that's the difference between if it's a base number, you're taking the root. You're actually finding what you take times itself to get that number, right? Versus these other ones, you're just dividing the exponent, which is like taking the root, right? A to the 6th times a to the 6th times a to the 6th 3 times will give you a to the 18th power. So you are trying to find what number or what value you take times itself 3 times to get you 18, but it's just that when you have exponents, you're just dividing to figure out what that is, right? So that's this part. All right, let's do D. This one is a square root, okay? There's no number there, so it's a 2. And we have a negative. The square root of a negative, I'm going to have an imaginary number, so I need to include I on the end of there, okay? If I'm taking the square root of 289, it's like, what do I take times itself? 2 times to get 289. So the square root of 289. I don't think that, oh yeah, 17. Okay, so the square root of 289 is 17. I know that this is going to give me an I. The square root of c to the 8th power means I'm just dividing by 2, right? Dividing by 2. C to the 8th is c to the 4th. D to the 4th becomes d squared. And I just want to combine that all together. So I would put, let me erase my I here. I would put 17 c to the 4th, d to the 2nd. I would put the I at the end. Okay. Technically, it doesn't really matter. You can either put the I at the end or the I right after the 17. I usually just put them at the end, though, okay? But break down each piece individually, okay? Let's go to the next one. Simplifying using, I don't necessarily want to do absolute value. Don't worry about the absolute value part of it. Let's just do this like we have been doing before. This is the 4th root. So I'm doing the base 81, and I want to know what number do I take times itself 4 times to get 81? And I think it's 3. If you take the cubic root of, or the 4th root of 81, it's 3. 3 times 3 times 3 times 3, 4 times gives me 81. Okay, then this is an exponent, x to the 4th. So I'm taking 4 and I'm dividing by 4. And that is just x to the 1st power, right? So 3x is going to be what you get for the 4th root of 81x to the 4th, okay? Don't worry about the absolute value for now. We'll maybe talk about that later, okay? Part B, we're doing the 8th root. So what do you take times itself 8 times to get 256, okay? So this is the first part. What do you take times itself 8 times to get 256? I want to say it's like a small number, like 2. 2 to the 8th power is 256. So this guy is going to become 2. Then this whole chunk, all of that is to the 24th power. Don't worry about this guy. We're looking at this piece as a whole is to the 24th power. So here I just divide, because that's an exponent. And 24 divided by 8 is 3. So it's just this stuff to the 3rd power, okay? Now notice when I do this process, the radical here goes away because I'm taking the 8th root. It's like simplifying it. Okay, I'm breaking it down into that. So the 256 became 2. This stuff became just to the third power. My root is gone, and that's what he looks like. Okay, all right. Let's go and talk about, we've already talked about this before. If I have 125 to the 1/3 power, that just means the third root of 125. I said that at the very beginning, okay? And then we can simplify that, right? The third root of 125 means what do you take times itself 3 times to get 125, and it is 5, okay? Now over here they did the same thing. The 1/2 power means the square root of -49. Now we know you can't take the square root of a negative number, so we know we're going to have an I in there, but 49 is 7. So 7I is the answer to that problem, okay? And that is converting rational exponents, so like fractional exponents or rational exponents into roots, okay? Now, what do we do when they have like 125 to the 2/3 power? Okay, now I just pretend that this says 1/3 to begin with, and I just make that a cubic root of 125. When I'm done with that, then I take it to the second power. Okay, so since the 2 is on the top, I'm just going to save that for later. The 2 is going to be my exponent that I do. The 3 on the bottom is that root, okay? So I take the cubic root of 125, which we know is 5, and then at the very end, I take that to the second power, okay, which is 25. So the final answer to that is 25. Okay, same thing here. I wait on the 3. The 3 I just save, and I do the square root, because that's my bottom. The bottom is the root. Okay, the square root of -49, which we know is 7I, and then I take that to the third power, okay? 7I to the third power might be a little bit confusing. We needed a step in between this and this to see how we get to that, okay? So 7I to the third power is 7I times 7I times 7I, okay? So 7 times 7 times 7 is 343, right? Okay, but then if we just take this I times this I and I is I squared, and I squared we know is -1. Maybe we should put that over here. I squared equals -1. So I've got -1 here, and then I've got another I. So 343 times -1 times another I, that gives me -343. That's where they came up with that from. So we have 2 I's, which make just a negative, and then the extra I hanging off the end is just this guy right here. Okay, so that was a little bit more confusing. Let's go and do this one. They want us to write it in radical form, okay? So again, the 3 tells me, the bottom number tells me what the root is. Now this time, they, instead of writing it the way that we were seeing it before, which is this to the 4th power, they wrote the 4 underneath. And I am here to tell you that these two mean the same thing. It doesn't matter if you take the 4 underneath like that or take the 4 out on the other side. You can take it to the 4th power first and then take the cubic root, or you can take the cubic root first and then to the 4th power. It doesn't matter what order they go in, whichever one you prefer. Okay, so that is part A. You can either write it like this or you can write it like this, but the bottom number tells you the root, and the top number tells you the exponent, okay? Now this one, they want us to write this in fractional form. So the 2, this is going to be my exponent, that's my top number. This is going to be my bottom number. So this is just x to the, again, the root is the bottom number, so the 5 goes here, and the 2 goes up there. So this is x to the 2/5 power, and that's what he looks like going back and forth between the two, okay? All right, we got a little bit left. I'm going to skip example 4, but then let's talk about one more kind of weird thing, 2 more kind of weird things that they can do to you, okay? So 2/5 will make that, let's just pretend for just a second that that doesn't have a negative there. This is 32 to the 2/5 power. Let's just pretend that it just says to the 2/5 power, okay? We are going to practice this, and the 5 becomes the root. So the 5th root of 32, I'm going to take that number to the 2nd power. Great, right? The 5 goes to the bottom. He's the root. So then I ask myself, what do you take times itself? 5 times to get 32. You might need to do that in your calculator. But 2 times 2 times 2 times 2 times 2, 5 times will give you 32. So this is 2, and I still have to take him to the 2nd power. 2 to the 2nd power is 4. Great. That is 3 to the 2/5 power, but I want a -2/5 power, right? So when you have negative exponents, what happens is, like 4, it was the answer to that first question. This as a fraction is like 4 over 1. Any whole number as a fraction is over 1. If I want to flip him to the bottom, that's when the exponents become negative. So if he was to the negative power, this is not going to be 4 over 1. This is going to be 1 over 4. And that's the only difference, is that that negative exponent is going to flip him to the bottom. So they did it to begin with right here. They flipped it to the very beginning. They did 1 over 32 to the 2/5 power, and then they figured out 32 to the 2/5 was 4. This guy became out to be 4, so it's 1 over 4, okay? We did it the other way. We resolved it first and then put 1 over that number, right? But that's just what that negative exponent means, is that that value is going to go to the bottom, okay, the denominator. All right, last thing. When you are multiplying x to the 2/3 and x to the 1/6, okay? Think about like when you're foiling. So like let's say I had x squared and I had 5x minus 2x to the 3rd, right? Like if I'm distributing this through, x squared times 5x is going to be 5x to the 3rd power. This is like x to the 1st. We're adding these exponents, right? This guy times this guy is negative 2 x to the 5th power. I'm adding the 2 and the 3 together. It's the same thing here, but it's just kind of ickier. I'm multiplying these two, so I'm adding 2/3 and 1/6 to get together. So 2/3 plus 1/6, okay? 2/3 plus 1/6. When you're adding fractions, you have to find a common denominator, all right? So if this is 6, I can make this 6 by changing this to a 6, then this has to change to a 4. So 4 over 6 is the same thing as 2 over 3. Then I can add them. 4 plus 1 is 5. 6 stays on the bottom. You don't add those together. That just stays 5/6. So the final answer is x to the 5 over 6 power. They don't have you switch that around, but if they wanted you to rewrite that as a radical, the 6 is the root, and it's x to the 5th power. So you could put the 5th power there, or you could put the 5th power outside. I know I'm kind of going fast, but if you need to pause, go for it. Last one, I think. Nope, we got 2 left. Dang it, 2 left. Okay, y to the negative 2/3 power. I'm going to do their strategy, and I'm going to move that down to the bottom. So look at what they did here. They put 1 over y to the 2/3 power. I don't want to do that. I don't want to do that. I don't want to do it like that. I don't want to multiply by this stuff. That's too complex for right now. So what they did was they multiplied by 1/3 to get that to be y to the 1st power on the bottom to make it nice, and I don't want to do that. So I'd skip part B. I don't want to do that yet. That's a little too much for me right now. All right, last one, C. Multiplying, again, you're adding these exponents. So negative 1/3 plus 3/4. I have to find a common denominator. So I'm going to make denominators of 12. So if I make this 12, I would have to multiply by 4. So this will be, let me move him down. This will be negative 4 over 12 is what 1/3 is. Okay, this guy, I have to take him times 3 to get that bottom to be 12. So this guy will be 9 over 12. And negative 4 over 12 plus 9 over 12 is 5 over 12. So the whole answer will be z to the 5 over 12 exponent. Okay, and again, that's the 12th root of z to the 5th power. Either the 5's on the inside or the outside. So there's a lot to throw at you today. For homework, start on 319, 2 through 26 evens. Start on those. We'll come back tomorrow and we'll answer questions on this section and then the other one that we were supposed to turn in today. Okay, and we will work on that. Okay.